Hey everybody, how's it going? We are on episode 3 of making a game from scratch. Last week we did some camera work, added some world generation to make sort of like a top-down isometric game, and spent some time making a coordinate management system as well as having a character kind of running around. So if you get, let me know if audio needs any adjustment. So this time around, I asked everybody kind of what they wanted to see, and we definitely need to get some rippling tiles in the terrain. So I'm going to pull up the game so we can just kind of see how it's looking right now. I have some ideas on what to do today. All right, so here's what we got. We're generating some rooms, and these little blueberries kind of represent the center points of the rooms. And the rooms can overlap, so you can see like we have 3 rooms kind of crammed together. And you also notice that I can just walk off of ledges, so the terrain actually isn't doing anything mechanical, it's just kind of there. And we are also doing edge detection, so we know what the edge of the terrain is, and we are changing the tiles based on that. So we've got kind of the start of a nice little sort of environment here, but we still don't really have anything to do. And so I think today we're going to be still working toward sort of finalizing and establishing the terrain and what this world is going to look like and how we're going to navigate it. And we might end up being able to spawn some stuff on the tiles and stuff sort of by the end. So let's take a look and see. All right, so the first thing I wanted to do is switch over to an isometric grid. And you'll notice that this is a rectangular grid, so every tile we have is a little rectangle, and I can pull up the sprites here so you can see. So this is our dirt tile, and this is our edge tile. So these are just rectangles. The issue with a rectangle grid is you only end up seeing 2 sides of any given object, and so you don't quite get as interesting of visuals. So if we switch it over to a diamond-shaped grid, then now we can see 3 sides of it, which then gives things a lot more of a feeling of depth. So I'm actually going to pull open Inkscape and start making some diamond-shaped tiles, and then we'll go back into the game, bring those in, and we'll update our grid coordinate system to handle isometric grids. All right, so let's get Inkscape open. Okay, so first we're gonna want to lay a grid onto the screen. So in our document properties in Inkscape, I can pop open the grids section, and I can just switch to an axonometric grid. So if I do that, you'll see in the background, I now get this nice grid, which is actually already proportioned pretty well for what we need. And we want our grid to be kind of similar in size to what we originally had. Our original grid was 100 pixels wide by 70 pixels tall. But you'll see pretty soon that an axonometric grid will end up needing sort of a bigger tiles than you might expect in order to make it feel like it's sized well. Okay, so you can just follow the major grid lines here in Inkscape as you do this. And then up at the top, we can see, actually let me just fill this in with the color so we don't have an outline. So at the top you can see, so this is 184 by 106. So remember our previous tiles were 100 by 75. And you might think that this sounds kind of big, but it very well may not be. Let's just see real quick if we need to turn on our grid snapping here. So what happens if we kind of tuck this in? And now this is 153 by 88, so it's a little bit taller than it was, but 50% wider than it was. So I'm going to actually go ahead and use that original size. It's going to sound pretty big, but once we get it in game, I think it'll look okay. If not, we can always adjust it. And so for now, we can just use sort of a simple gray one, and just we'll throw a bottom piece on there for some extra depth. Whoops, messed that one up. So if you have a hard time drawing, like if you're mostly a programmer and your art skills aren't up to par, Inkscape is a great starting point. It uses vectors, and so you can just keep sort of like, wiggling things around until it looks the way that you want. And if you don't have that sort of manual dexterity of, of being able to draw clean lines or something, then vector art is your way to go. Okay, so we're going to give the top a much brighter color. Okay, so we just have this nice little tile here. And I'm also going to put a bounding box around this. That is way too large of a stroke. Okay. So I'm going to put this bounding box on here, and that's going to allow us to add some extra flair to this tile a little bit later on. So if I exported it just exactly as is, then there'd be no extra room around the edges. So I want to make sure that I kind of account for having some extra, potentially some extra stuff around there. And I'll want this to be centered in the bounding box, and I can still use the grid for that. It's a little bit weird because of the shape of the grid, but everything looks centered pretty well. So let's export this out. And I'm going to go ahead and export this into the folder. So we'll call it the art folder, and this is going to be PNGs, and this is our just call it tile main. Alright, so I'm going to add that in. Import that. Go to game dev. Go to our stream game. Whoop, whoop. Got to actually hit the export button over here. Let's actually look at our width. Yeah, so you notice that because I was using the width and the height up here, then when I come back to my selection, if I keep this at 90 DPI, then it'll automatically export at the right pixel sizes. So as long as you aren't changing your export sizes in Inkscape, then you're going to end up with some like weird scaling issues. Let's see. Get some questions over here. I'll add some category or tags to the stream. Yeah, let me do that. Oh, it's under the creative thing. Let me get some tags in here. Thanks for the note. Okay. How do you determine the spacing, Shamus is asking. You mean the spacing around the edges? Yeah, they moved game development used to have its own category, and now there's just science and technology, which seems a bit odd. Alright, so we've exported our tile. Let's pop back the game open. SP tile main. Okay. So we've got our image here, and you'll notice that my origin is... so the size of the bounding box on the tile is really just up to you. It's just kind of how much extra space you think you might want in the event that you want to add some flair to the thing. I mean, you definitely need to export, up to the area that is visible, but you can go You can go outside as much as you want. And GameMaker will crop these down inside of the texture page manager. So any blank space around it just doesn't really matter. All right, so what we're going to do here is we're going to move this origin point to be in the center of our tile itself. So first, we need to figure out where the Y is, which we can just do by clicking on this left area, like that. So our Y center is at 71. And the X, it's already centered on the X. So now we've got our origin set right back to the middle point of the standing surface of the tile. Tile main. So for starters, we can just straight up swap this thing. And you're going to see that it's going to be ridiculous. So one of the things I'm trying to do on stream is change things little bits at a time and show the outcomes so you can kind of see how they end up getting pieced together in the game. So this is just straight up still using a rectangular grid, but swapping these new tiles in, which actually kind of looks interesting. But that's not really the effect that we're going for. So next up, we need to update our grid management. And if we go back into Inkscape, we can click on this main tile here, and we can see that it's 184 by 106 over here. And so that's going to be our new grid size. Okay, so 184 by 106. And let's hit play again. So this is going to be even weirder because we're still in a rectangular grid. So, you notice now we got these big holes. So if we really want to convert this thing to an isometric grid, we're going to need to do some pretty bizarre coordinate conversion math. And so let's just do it. So previously, if we wanted to convert grid to X, X to grid, back and forth, we can pop this open and look. All we had to do was just like take our grid space and multiply it by grid width, or grid height by the grid space. Well, an isometric grid is a bit of a different beast, and here's why. So let's say I wanted to make a grid. So I'm gonna see if I can pull this off in Inkscape so you can kind of see what makes this odd. Okay, so I can snap these together. I'm just gonna make like a 3x3 grid to use as an example. With coordinates. Okay, so if we're on a rectangular grid, then as we go to the right, then our X goes up, and that's pretty understandable. As we go down, our Y goes up. So this ends up being 1, 1, this ends up being 2, 2, this ends up being 2, 1, and this ends up being 1, 2. Right? So if we go to the right 1 and down 2, it's 1, 2. And since the world has the same function, where like if you go to the right in the world, your X goes up, and if you go to the right on the grid, your X goes up. Well, with an isometric grid, we now have to, let me just transform this thing. I'm going to rotate this by 45 degrees. Okay. Squish this down. Okay. So now we've got an isometric grid. And this is now a nightmare, because if I go to the right on my X, so let's just say I start at 0, 0 and I just travel to the right. So I'm going to make this thing red. Let's put okay, that's sort of an arrow. Wait, I think I actually have arrows. Okay, so I'm going to go to the right. But what's happening? Well, I'm actually going down on the grid and right on the grid. right? So as I go to the right with my X, my Y grid goes up. And if I go down on the grid, let's say I'm starting up here at 2, 0. As I go down on the grid, my Y goes down, or my X goes down and my Y goes up, etc., etc. So we have this kind of new sort of fresh nightmare of coordinate management where I can't just easily turn X into world and world into, X into grid and grid into X. I now need to know both my X and Y position to get grid coordinates. And in order to go back the other way, I need both the grid X and Y. So let's do that. And I solved this problem a long time ago in Quadrupus Rampage for coordinate management and isometric grid. And I haven't done it in a long time, so bear with me. All right, so instead of doing grid to X or X to grid, we're going to say grid to world. Okay, and we're going to give an X and a Y grid coordinate. And we're now going to actually return both an X and a Y as an array. Okay. There it goes. So we're going to fill up this array. This is going to be our world Y position. Okay, so the math is... so we're going to round this thing. So to go from grid to world, we have to go... Actually, sorry. We don't need to round it because that's the other way. To go from grid to the world, we need to take our X grid and our Y grid, add them together, multiply that by grid width times half. Because remember, as we move to the right, our grid X is changing and our grid Y is changing. And our Y position ends up being this in the world. So we need to take both of these things into account. Are we making the tiles move when you step on them today? Yeah, that's the goal. But first we want the tiles to look a little bit better. So, and we may also want to kind of fray the tiles and do something about making them so it's not just perfect circles all the time. All right, so this is our grid to world. And then we also want to flip it around and have world to grid. Do I prep for this, or am I doing everything on the fly? I had to go back and look up the conversion method for isometric grid because it's sort of mind-bendy. So if I know there's something that I'm doing that I haven't done in a long time, I'll refresh myself on that. Okay, so world to grid. We're going to do the same thing here. This is going to return an array that contains X and Y coordinates. Just for clarity, we'll say world X. All right, so for this one, we're going to be doing, we're going to be taking our grid width, let's see, times, or sorry, divided by half of our grid width. And remember, as we go right on the X in the world, our grid Y also goes up. And weirdly, to get our, let's let's see, I think we're missing a paren here. To get our Y position, we just do the opposite, because our Y goes up as our Y grid goes up as our X world goes up. Blah, blah, blah. I think this is right. So we will give this a shot. Let me just double check. Yeah, I think so. Okay. So now I'm just going to use Control-Shift-F, which is my search and replace. I'm going to look up grid to X. Whoops. And we're going to see where we're using this. Okay. So here we're converting to grid coordinates. So XY equals grid to world. And now we will just use our new values. Okay, and I think we have one more spot where we have this, yeah, making berries. Equals to world. So I'm just going back and I'm refactoring areas in the code where we had grid conversions, and we're gonna switch this over to the isometric grid we just made. Okay, so I think that's it. Okay, so we do have the isometric grid. However, the depth sorting is wrong. We have sort of like an MC Escher bizarro world going on here, where some of these tiles are on top of others where they shouldn't be. And so the reason for that is if we go into our stage generation, here we are spawning the tiles, but up above we are spawning the tiles in a certain order, and that order, let's see, is right here. That order is based on what previously was just their Y grid position. We go back into our reference and look here. The grid Y position is no longer a reliable indicator of where the thing is vertically in the world. So just because something has a higher Y, like let's say this has a higher Y than this, right? But this is actually further down. So we can't really use that anymore, and instead we have to directly convert the grid coordinates. So this world XY is grid to world. This XY 0. All right, so developing coordinate management systems it can be pretty mind-bendy, and it can take some time, but once you figure out the mechanics behind converting your coordinates in the world, then you just create some scripts for it early on in your project, and then you never have to worry about it again. And the cool thing about this is, since the world is being generated by code, then we can change how we interpret grid coordinates and just change something from a rectangular grid over to an isometric grid without too much fuss. So, okay. So now we've got pretty good looking isometric tiles here. Could you add jumping and various heights to this? Yeah, well, one thing we're going to have to do is we're going to have to manage the height of things, because if we're going to ripple the tiles up and down, then that means things are going to have to stand on those tiles, and those things are going to have to know where they can stand. And so that's all going to be part of it. So my character feels a little bit small now because I kind of blew up the size of the grid, but I think that's probably fine. I think the world feels good in terms of how many tiles we're seeing on screen at a time. So I'm going to push this out. So if anybody is on the repository through GitHub, you can pull this down. And we're going to say converted the world to an axonometric grid. Oops. Origin master. And I'm also going to delete these old grid coordinate conversions because they will confuse and they're no longer used. I'll just quickly run the project just to make sure there's no reference to those. My on-screen text seems to have stopped updating. See what I can do about that. Yeah, I don't know. Okay. That's right. I'll read questions out as they come in. Okay, so we're running around. Everything looks good. We've lost our edges now, which kind of sucks. And I kind of liked that visual. So maybe we can go back and add some new edge tiles. I'll keep this in here for reference. I'm going to actually save this SVG file in the stream game folder. So let's put it in here. SVGs. We'll call this environment. All right, we're gonna want another tile. So you guys in the repository, you'll have access to these Inkscape files as well. So you'll be able to open them up and do whatever you want. Okay, let's make an edge tile here. It could be really anything. We still haven't really settled on what is even happening in this game. So everything's kind of up for grabs. Maybe some kind of weird tealish thing. It's kind of a nice color. All right, so we're going to export this as tile edge. Create sprite, import tile edge. And same, it's going to have the same origin as this one, 71. And one thing I'd like to do actually is I'd like to standardize setting the origin of these tiles. Let me get rid of these old ones. So you notice that one option here is like every time I import one of these tiles, I'm now going to have to go in and reset its origin, you know, to 71 or whatever. There's another option here, which is that I can set up some kind of a mechanism to just duplicate the origin of my main tile across any new tiles. So let's take a look at that. Initialization object. Make a convenience function about sprites. So these are all now totally. One thing I miss about old GameMaker is the ability to instantly alphabetize your folders. Okay. All right. We're going to make a script called copy sprite origin. Main sprite. And we're going to allow this to copy across any number of sprites. Oops, argument count and argument 2. And this should actually be 1. So I'm flying off the rails here. Sprite to copy 2 equals argument I. Yeah, you can definitely alphabetize folders in GameMaker 1. It's the one feature that GameMaker 1 has that is better than GameMaker 2. Okay, let's see. Sprite to copy to, argument 1. Sprite set offset. Sprite get offset. Oops, sprite get x offset. So you can actually change the origins of sprites. Interestingly, so I can just say sprite to copy to. Maybe for clarity, I can just call this x offset and y offset. Cool, that's pretty nice. So then in my initializer, copy sprite origin from SPTL main over to SPTL edge. So what this would mean then is if I ever wanted to update the origins of my tiles or update the sizes of them, then all I got to do is just change it here on my main tile, and then they'll all be updated on their own. So that's super nice. And actually, for name and clarity, we'll say sprite copy origin. So we have that, and let's go back and finish this off by updating our edge sprites to spawn the new one. That could be too bright. Or maybe the interior is too bright. Let's knock that down a peg. What goes well with this kind of tealish color? Something like that. Do that. This would be the point where I would probably look up a color palette somewhere and borrow one. I may do that off stream and update it tomorrow. Knock down the saturation a bit. This might be a little too saturated as well. Okay. Let's update our interior tile to be less crazy. Tile main. We don't want to blind everybody, right? Not really feeling that, but that's all right. We can move on. We can fiddle with colors all day. Okay, so next we want to finalize our room generation. I'm going to push this out. So we have now sprite origins of tiles are copied. And cleaned up old grid management. Hey, thanks for stopping by, Kyla. Okay. Yeah, you know what? You know what? I gotta fix this. I don't want to look at that. Let's get that gray out of here. I feel like you don't want to put yourself into a position where you don't like to look at the game that you're working on, even if it is just a color shift or something. This interior to kind of be like dirt, I guess. So I'm just adjusting these values. Then we'll get some darkening on the edges and desaturate those edges quite a bit. And then this area is way too overblown. So I think going back to kind of like what we had, where we got some grays in there. Can maybe give it a little bit of greenness. All right. Feeling better about this. Tile main. Tile edge. Oh yeah, this is going to be so much better. There we go. There we go. Okay. Push that out so nobody has to look at that. Made the terrain less hideous. Yeah, one aspect of this kind of iterative development is just work on whatever you feel is the most important at the time, even if maybe mechanically that may not be the case. If you got an aspect of your game that just looks terrible, then just fix that, you know? Okay, so I want to update the room generation, and we can take a look at what the current situation is, which is we spawn these rooms. As we walk around, you know, they aren't connected. So once we add edge detection, where like I can't walk off of ledges anymore, then all of a sudden I'm going to be just trapped. So that's one problem. So we need bridges in between these rooms. And the other issue is that the rooms overlap quite a lot. So let's fix the overlap first. Okay, so what we're doing right now is when we set the locations of the rooms, we generate a room and then we pick a new direction for the next room. And we don't do anything like, we don't check whether or not that room is going to collide with an existing room or whatever. So we can now do a little bit of iterative work and try to find where to go from there. Yeah, we may end up not worrying about the overlap in terms of like guaranteeing it, but we also don't necessarily want like 5 rooms to overlap on top of each other, so we want to kind of bias it a little bit. So we can do that by just saying main direction. So we'll pick like a general trend for the rooms to go. And we will pick, so our new room direction. So first we could just say like this. So just to kind of give you a feeling for what's happening here. So now we've picked a direction, and you notice like all of our rooms are now going to just spawn in that one direction, which is probably not necessarily what we want. So instead we say main direction so we could give it like a 180-degree arc in that direction. Actually, I'm going to, while I'm working on room generation, I'm going to see about set view size. I'm going to see about blowing up the camera. Let's see. Right now we're at 1920. Get, let's say view, W view, or view width. One of the key aspects to making things move quickly is making your work more visible. So notice how, like, hey, I can actually see my room generation now because I zoomed out. Weird. Okay, so this now you can see we started up at that top area, and the room generation now kind of goes downward. And let me actually also add, I'm going to add just a debug hotkey to regenerate the room. Hey, Runo, thanks for stopping by. Yeah, I'll have the VOD up on YouTube. So, all right. So if we press R, then we're going to just do a room restart. So all I'm doing here is I'm just adding some extra debug stuff, which will allow me to quickly and easily. All right. So what's happening here is when I restart the room, we are not clearing stuff, right? So it just keeps piling on. So that's obviously something that we have to fix. So, gameplay controller, room end, clear world tiles. Let's fix that. Stage generation. All right, what are we doing here? Clear world tiles. So we're putting all these into a layer, right? World layer. Question is, if we destroy the world layer, what happens? Do the things in the layer get destroyed? I don't actually know. No, they do not. So you can destroy a layer, and the things that were in the layer are still there. That's the problem. So we now need to actually keep track of our tiles. Tiles list, and when we generate our stage, we are going to, so here we have our tile, and we're going to just add tiles list. So we're going to add that to our list, and then when we clear the world tiles, let's see, so we're doing this layer sprite create. Tiles list. So we're just going to iterate over this list and grab each tile out of it. I call them tiles. GameMaker and GameMaker, they are layer sprites, but hey. All right, so this should, in theory, clear out our tiles. But it's not. Presumably, maybe because room end does not get triggered on a room restart. So what if we said room go to room? Nope, nope. Let's double check and make sure that this is actually triggering. And I don't think we have, Oh yeah, we have our echo function. So I'm just going to say cleared world tiles. So I'm just going to put this in here and make sure that this is actually being triggered. All right, so it says it's clearing the world tiles, but it is not. So there's a couple possibilities here. First, let's move this and make sure that there's not something bizarre happening in room end. Okay, okay. Looks like we got our first debug black hole that we got to go down. All right, layer sprite create. SP. We are adding it to our tiles list. Am I simply... Layer sprite destroy. Clear world tiles. Let's not worry about changing the room. Let's first just... All right, so it is clearing them. But when I change the room, it's somehow messing with that. What does that mean? Gameplay controller. I'm going to generate the stage. Yeah, so it looks like in both cases, if I restart the room, then the tile clear doesn't trigger, but it does trigger if I don't restart the room. So I'm going to have to figure out some kind of unusual workaround. I wonder if I just do it on the next step. Restarting room equals false. If restarting room. So if we just do this, this means that when I press this, then the next step it'll restart the room. So it'll clear the tiles in one step and restart the room. The next step, I don't know. Wait. No. This is working. We just have something else stupid that we're doing. Aha. Okay. Check this out. Generate room. Room centers. We're not clearing this. So it actually is just regenerating the tiles. It's regenerating the rooms every time. All right, so we have our terrain locations list. We have our room centers list. Just list clear terrain locations. And actually, just for safety, we can probably just clear the world tiles. Yeah, so actually, we may have not even needed to iterate over these things. We might just destroy the layer. Let's just check real quick. Like, what happens if we just destroy it? Okay, yeah. All we had to do was destroy the layer. So, you know. Clear world tiles. Destroy the layer. I'm going to keep that tiles list, though, because I think that's going to be useful later. Yeah, these are the kinds of bugs that you get to spend all day on, and then at the end you're like, oh, yeah, okay. Subtracted when I should have added, or something. Okay, so we have our terrain locations, room centers, and our terrain types. So let's see, clear world tiles. So we don't even need to run clear world tiles because the stage generator will do that. So, okay, now we have some good stuff. So you notice how we still end up with some rooms connecting and overlapping with each other, which is nice. So if we want to give us a little bit more oomph, we could say angle range. So right now we are going -90 to +90. So we could try even like 130. So that means we're in like a 260 degree, which means actually sometimes it will go backwards, but it will trend away. Right, so that kind of lets things clump up a little bit more, but it keeps those, it keeps rooms from overlapping so hard as they used to. Okay, and so some of the stuff that we can do over time is like maybe as we progress through the game, we can maybe like add more rooms. So right now we're doing, 5 to 10 rooms. What if we did 5 to 100 rooms? This is probably going to lag a bit when we spawn. You know what? I'm also going to just totally blow up the player's move speed. So we can really just zoom out there, So we can kind of see what sorts of things we're doing. So it looks like in this level, we start at this little spot and kind of work our way out, and we would need to fight our way. We'd find like this big platform with lots of stuff going on. So it looks like our randomness is making some pretty decent stuff, I think. All right, so I'm going to push this, and then we'll work on some bridges. Updated room generation to be biased toward a direction. All right. Next step, generate stage room. Generate stage. All right, so we are generating a room, and we probably also want to generate a bridge. So generate stage bridge. So we're going to go from an X and a Y to the idea here is we need to create contiguous spaces. Okay, so we're not going to worry about this. And all we're going to do is we're just going to kind of work our way toward the destination and set the terrain at that position. We also have a duplicate here because we're going to need to redo this, which is we're going to place terrain at a position. So I'm going to add a script, which is set terrain at position. Let's see, generate stage room. So we're going to take this chunk here, and that's going to be our That's going to be our terrain set. XG, YG. Chords. Generate stage room. Looks like our syntax highlighting just broke. That's just white. This is no good. I'm going to have to reboot GameMaker in a moment. Generate stage room. So here's what we were doing. Now we're just going to say set terrain at pos. There we go. So that's what we were doing. And now when we do our bridge, we don't have to worry about this. We're just going to now kind of snake our way over to the destination and set the terrain on the way. So while so as long as I'm just gonna take I'll call this current actually. So we're going to say, where do we start? Where do we go? And every time we generate a room, we'll generate a bridge from the previous room. And later on, when we update our terrain generation, we can do stuff like fray the edges or kind of like punch holes in the ground and stuff to just make it a little bit more interesting. And we can also update that to make sure that we don't ever tamper with bridges. So that way there's always a purposeful thread in between. See you later, Retro Banana Man. Thanks for coming by. Okay, so first we're going to say dir to move equals point direction, XG current. So we're going to figure out what direction we're going to work our way toward, and then we're going to go there. Okay, set terrain at pos, XG current, YG current, and that is going to be terrain type dot interior. So we could make it an edge so we can actually see the bridge pieces. Okay, direction to move, and we're going to move toward that, and then we also probably want to round this to the nearest 90 degrees so that we don't end up with diagonals, because otherwise we'll create a bridge that you can't potentially cross. So that's another convenience function that we'll make. And this is just going to be math. Round to nearest. Round number. So we want to round this number to the nearest 90 degrees, which means we need to return number divided by the round number times the round number. Right? I think that's right. Somebody correct me if that's wrong. If not, the game will. Okay, so we are going to generate our bridge. We're now going to looks like our syntax highlighting came back, so that's nice. Not on that one. Generate stage room, generate stage bridge. Actually, let's make a bridge terrain piece so we can just debug it and see. So this just needs to be visually distinct from the rest. So we don't really plan on using this in the game, but we just want to be able to see it. So it's gotta be pretty garish. Hot pink. Tile edge, bridge. Bright, import, bridge. TL bridge. Once again, not going to worry about setting the origin by hand, just going to do it over here. Okay, so when we set our bridge, oh yeah, we gotta actually do this. Okay, so we're gonna set our terrain there, and then we are going to we're going to move our X grid and Y grid by 1 in that direction. And even though this should be fine, just for safety, I'm going to round it. Okay, and then to see our bridges, when we generate our terrain type, let's find where, okay. So here's where we are updating our edges. And we want to first not touch it if it is a bridge. So we'll say, let's see, if terrain types this word equals, we're only going to change it to an edge if it's an interior piece, and otherwise we're going to just leave it alone if it's a bridge. Just for now, so we can see it. Now we're going to update this to a switch statement. So if it's an edge, we're going to spawn the edge sprite, just like before. And now we're going to switch bridges to that. And last we need to actually call this generate stage bridge script. So here we have our generate stage room. And we now have our new room. Actually, I think we can not even worry about this, and we can just iterate over the room centers themselves. Oops. All right. I accidentally hit my share X hotkey. Iterate over the room centers, and we are going to... Actually, now, yeah, let's do this in the room generation here. So here we know where the new room position is. The old... right, so before we update the room positions, we'll store the last one. And then we can generate a bridge. I think we want to do this beforehand. Kind of flying by the seat of my pants here, but that's, you know, standard. All right, so we're starting to get some bridges, but we didn't solve that rounding problem, right? Because these should be rounding to the nearest 90 degrees, and they totally aren't. You can also see that as we spawn each room, then it overrides the bridge. So there's that kind of weird issue as well. So actually, yeah, we might need to generate the bridges afterwards. After all. So let's do that. Don't need to worry about this previous room nonsense. So we'll get the current room and the next room. And we'll use our coordinate conversion that we did from last time. Or to grid. And get the next room, XY. And we just do what we did up above, except now we're doing it after we make all the rooms, which should allow us to punch through, I think. Nope, so it looks like we were refusing to place terrain unless we didn't have any there, so this little tweak I just did should allow us to take care of that. So let's give that a try. Then we'll work on fixing that rounding problem. Oop. Type, array, expecting a string. So it looks like, oh, we ended up adding, oh, our room centers are actually an array. So, whoops. We actually don't need to do any conversions because we put an array in a list, which is something I don't normally do, so. That didn't do what we needed to do. How far does this go? All right, we're only going zeros. All right, derp. Ooh. So now you can see we can follow it. Goes down like this, goes up over here. Then this apparently goes to this one, and this goes to this one, which then goes to this one, then this one, or something. Okay, so yeah, so the reason I'm highlighting these bridges in pink so that you can kind of see just what the heck is going on. Okay, so there's some other interesting stuff that we can do. First, let's fix this rounding problem here. All right, dirt to move. Round to nearest. I think I just have my round in the wrong spot. Or my parens. Yep, that was it. All right, so now you can see we have contiguous terrain going on. It's a little bit easier to kind of see and understand. Oh, we got some Spanish going on in the channel. I like it. Makes me feel like I'm at a Democratic debate. Okay. So the question about these bridges is it fine for them to be one grid space? All right, so just to check out the visuals on this, let's just see what this would look like. Let's see, check stage. So when we detect our edges, here, let's just get rid of that. Say, if not edge, then we'll replace that bridge setting with interior. Okay. So this is definitely not as interesting, right? Just having like a straight line. So one thing we can do here. Okay. With our bridge stuff, right now what we're doing is we're just pointing at the destination and we're just going to make the bridge in a straight line. We can actually mess with that by just giving some randomness to our direction, right? So when we go to move in that direction, we're just gonna randomly pick another, 90 degrees, 0 or toward. And because this is biased, then it'll get there. But notice how, like, we got a lot more bridge now. So our bridges are more interesting. Gotta give it that. But see, like, this is a good example, this bridge up here. So notice how this bridge kind of goes out, and then it like tucks back around, and then works its way back, and it's just doing weird, goofy stuff. But I kind of like it. And if we wanted to, we can push our stage generator, or push our rooms a little bit further apart. So we have this bridge length here. Like, what if we had rooms that were very far apart? Then we had to put these kind of weird things going on. And now last we can update our terrain setting here and take a look at how it would look if we visually treat the bridge the same as the rest. Okay. So that's pretty cool. And what you end up with now is you've got kind of like out here, we've got these floating areas that were just a big cluster of bridge pieces, but then by converting them, then they kind of get an interesting shape. And we're also going to want to like fray the edges of these circles so that they aren't just a bunch of circles connected by wild and wiggly bridges. But let's not worry about that just yet. I'm going to keep this as is. I'm going to zoom my camera back in for now because I want to get those tile ripples in. So my camera, I'm just going to fix that. Gameplay controller. I'm going to leave this in here and comment that out so I can quickly and easily flip that back out later. Hey, the Rumpus. Welcome to the stream. Oh, right. I gotta not be a jet engine. My bad, my bad. Okay, so yeah, the question is really just, how does it look once we're zoomed back in again? Does it feel right? Does it feel good? I think it does, although I feel kind of slow now. I think maybe I'm just accustomed to moving like lightning. Okay. Yeah, this is feeling pretty good. So I'm gonna push this out, and then let's work on that tile ripple thing. So this is the world has bridges. And once we have the bridges now, we can update the movement code so that you can't walk off of ledges. So we've set the stage for that, which is nice. Okay, how do we want to ripple tiles? Let's just think through it. Tile. What do I call this? Tile set Z. All right, so for starters, we actually need to start keeping track of our tiles so that we know which tiles are being rippled and moved. So let's see, stage tiles, or we'll say tiles spawned. So whenever we spawn a tile, we need to drop that tile into our tiles spawned list. So, sorry, into our map. So we know the coordinates, and that's our lookup, and we put the sprite in there. And we also need to clear that. I'd probably put these in here because that makes the most sense. All right, so we also want to keep track of tile Z offsets. And we're not going to put anything in there just yet. And last, tiles with Z offset is a list. All right, so we have to kind of set up some data structures here in order to keep track of which tiles are rippling, because we don't want to be iterating over every single tile. Instead, we want to, whenever we like make a tile bounce or ripple, then we record the fact that that's happening, and once it's done happening, we clear that out so that we don't have to worry about it anymore. Tiles with Z offset. All right. I think we're ready-ish. So we will say ds map. Let's go in here and grab our information that we're going to need. Just comment those out so we've got them. All right, so if we haven't already done this, we can use grid coordinates for now. We may need to modify that later, but all right. So if we haven't already been manipulating this tile's z offset, then we will add those coordinates to our list so that we can iterate over them later. Kyo is asking, does GameMaker use a regular programming language or does it have its own scripting language? Yeah, so as the Rumpus and Tim are talking about, GameMaker has a language called GML, which is kind of JavaScript-y. Yeah, the language is evolving quite a bit over the course of the next couple of years. All right, so we're going to add our tile to this list, and then we're going to tile z offsets, chords. And the other thing we have to do is we have to track tile start y. So this is a bit weird, which is if we want to essentially move the tiles vertically on the y, and we want to do that in a way that we can return them back to their original position. So when we first start setting them up, then we need to get their y position. Sprite equals. We also want to. We only want to do this if we're actually dealing with a location that has a tile in it. So that's a good thing to check. So we're going to grab the tile. Layer sprite get y. Tile start y. All right. So we're going to basically just kind of take a snapshot of where this tile is starting. And then we are going to go ahead and replace its z. Got our tiles with z offset. Yep. All right, so that's part one. So this is just sort of kicking it off. And then the next step is actually iterating over those tiles, moving them, and clearing them from the list once they're done. So I think we can probably do this in the gameplay controller for now. Seems like a sensible place to do it. Is list size, tiles with z offset -1. And we're going to start at the end of this list and then work our way back toward the beginning. Tim's asking, what does the question mark do in front of chords? The question mark is an accessor that allows you to look into a DS map. So that's basically a stand-in for doing. So here I've got this. This is the same as this. So these two lines of code do the exact same thing. The only difference is this first one doesn't give you a carpal tunnel. And you can do the same thing with a pipe in order to access values out of a list like that. So it's a nice time saver. All right, so tile set Z. I'm going to snag this code and just hold on to it in a comment for easy reference here. Yeah, once you get the hang of working with lists and maps, you can make some really interesting and elaborate game systems. Okay, so we're going to start at the end of this list. We're going to iterate backwards through it so that as we delete items in the list, we don't end up messing with our iteration. There's a problem, which is when you delete something out of a list, then everything after that gets shifted down. So if you start at position 0 and iterate up through the list, and you delete something, then now you're going to skip stuff. So we have to just make sure that we, in this case, we iterate backwards from the end of the list. This tile chords. This tile sprite equals tile spawned. So one note here is that this could end up being wrong, and this could return an undefined, in which case we'd have a crash. So. What are we building? Asks Farker Haiku. I'm just working on a little game project from scratch. Currently we have some room generation, character that runs around in the world. Don't really know where we're going with it, just kind of doing whatever the stream wants to see. So, all right. So we got this sprite. Right now we're working on making terrain that kind of ripples around as stuff happens. Okay, so our tile sprite is this, and this tile Z equals tile Z offsets. Layer. Oh yeah, we also need to get the starting point. Equals tiles start Y. Got to line up those equal signs, you know. I also like that these are all the same number of characters. It makes it, I don't know, it just satisfies me. Do you have a script to solve the list problem? Filling back in. It's not really script related. It's just you would need to change your position in your iterator whenever you deleted something, which is just kind of an annoyance. So it's easier to just iterate down from the end. Layer sprite. All right, so we need to set the Y position. I haven't worked with layer sprites too much. So layer sprite Y. I assume that just sets the Y. So let's try it. Tile Y start. And just for safety, let's make sure that we're doing our Z management properly. Looks like, let's see, Z speed, So our Z speed goes up, gravity, which means negative Z is vertical. So yes. Okay, so we're setting the Y, and then we want to change the Z, where we say tile Z offsets, or we can just say we're going to lerp it back towards 0. This tile Z. We'll do it kind of slowly at first so we can see it happening, and then we can speed it up as we go. And then if this tile Z, we're to the absolute value of that, and if that's just less than like a half or something, so if it's getting really close, like a half pixel away from its original position, then we will purge this whole thing. So we're going to delete tile spawned. Oh, sorry, not tile spawned. Z offsets. Keep tile spawned. Delete Z offset, start Y, and we'll also delete tiles with Z offset, current position. Okay, and then last, we should be able to test this by maybe doing like some kind of mouse clicks or something. So I'm just going to do that. So we want to say mouse grid xy equals world to grid. And we're going to now tile set Z. We're almost there. Then we'd figure out what to do with it. And we'll push the tile down by 50 or something. Oh, oh. Not quite doing what we want, is it? It's doing something. World to grid. All right, let's take a look at what's happening here. Here's the size. Oh, right. We actually are not replacing the Z. Just because we're changing this. Just because we're changing this in a variable doesn't mean we actually replace it in the map. So. It also looks like our Z is backwards, right? So we want to set it to plus Z. Let's actually do just if we're holding the button. Let's see what happens. Looks like our grid to world translation is not working properly, is it? Looks cool though. World to grid. GYG. Let's just make sure everything is fine over here. Let's see. World to grid. I think we have it backwards. Right? Yeah. All right, so it looks like we got to do some debugging on our grid translation here. So I'm going to make a new debug tool called spawn marker. So making some kind of a marker for yourself that you can just drop anywhere you need a visual reference is super convenient. So all we're going to do is we're going to make this thing called a marker. I'm going to give it pretty high depth. Radius equals 10. So this is just a little debug tool. Radius is 10. And color is white. And all this thing does is it draws a circle with a black outline around it so that it's easy to spot in all scenarios. equals second since update. And then we just make a script that spawns a marker for us wherever we need it. These markers just clean themselves up. So we need an X and a Y, color, a radius, and lifetime. Yeah, the rumpus. It does look cool, but we got to fix our grid coordinate issues. No marker. Oh yeah, we're gonna need a. Yep. So X and Y and lifetime, these are all variables that already exist. So we can't really use them simultaneously in here. Radius and color is that. Alright, so we have our spawn marker script. Now what we can do with our gameplay controller is we can just spawn a marker anywhere. So all we're going to do is we're going to convert the mouse to the grid and then back. Mouse world XY. A radius of 20 and a lifetime of just like a tenth of a second. So we just need these markers to just kind of exist. Let's see if this works for us. Okay. Looks like we're just doing something very silly. So we know that our world to grid works because, sorry, our grid to world works because our tiles are in the right spot. So let's take a look at the flip side. World to grid. I think it's just a parentheses problem. 0.5 times that whole thing. How many parens do you need? And let's also do this. Hey, look at that. Ooh. So you notice how this is snapping right onto the grid. All right, so let's get back out of this debug mode here. Don't need these markers anymore. Now we can see the terrain responding to the mouse. So, what's something you guys notice here? I'm not moving. The train is moving underneath me, and it has nothing to do with me. Which is a bit odd. So we're probably going to want to fix that. So I'm going to push this out. Let's see, fixed, a bug in coordinate translation, and the world tiles now can ripple. So we're not doing anything with those yet, but, you know, it's there. And I'm going to get rid of this commented code. Alright, so the player tile set Z. As the player moves around, we probably want to update the player's X and Y grid position. Let's see. Grid pos equals. Let's just do that. So as the player moves around, we're going to update the player's grid position, and then when the player bounces, can we like kick a tile down underneath? Feels like I should knock them down when I land on them, not when I jump. You know what I mean? Yeah. Alright guys, I feel like by the time we get to episode 30 or 40, we'll have a game mechanic. But you don't need gameplay in modern game development. You just need marketing. So we're gonna focus real good on the visuals. We'll go to E3. Have a good trailer. That's all you need. Okay, so looks like equals Z is less than 0. So we're gonna say, are you off the ground? If Z is greater than 0 and, or say was off ground. Can we like? Just kind of, you know, knock those grid tiles around. Still feels a little weird though because it's based on my exact center. So if I'm straddling grid spaces, then it's kind of like, you know. So I feel like I should probably check around myself a little bit. Kind of. Yeah, let's do that. Less than, let's see, dir less than equal less than 60 give myself 45 degrees. Ten 10.5. Direction dirt. And watch this. I'm now going to take into account that grid ratio that I calculated a while back. You'll see. So first I'm going to use my marker spawn. What's... Dirt equals 0. What? Dirt less than 0. Okay. X check, Y check. C red. Radius 10. We'll put that up for a quarter of a second. See how I've got like an oval, which mirrors my shadow. So this would be kind of like the area I would check if any of those spots are on a grid space. I obviously don't need that many of them because who cares? So if I go 45 degrees, that should take care of it. So I don't need to spawn these markers anymore. Equals world to grid. So now if we land in kind of straddling grid spaces, then we'll hit all of them. Okay, so things on the ground are not reacting to this. And it's also the case that our Z position is, you see here in our update Z, we are changing this based on 0. So that's kind of an issue. One option would be to actually check where we are, get the tile at that position, and then see what the Z offset of that tile is, and then change our maximum Z based on that. So that's one option. For now, I'm not going to worry about it too much. Just going to move forward. So we got about 10 minutes, and I think we can get, in the last 10 minutes, I think we can get it so that you can't walk off of ledges. So let's try to do that. Tiles now ripple when you step on them. So we got a nice little effect there. And we can later try to come up with some kind of thing where like maybe you do an attack and it kind of like blasts the tiles out or something. Maybe add a bounce effect to the tiles. We could add... It's also the case that the tiles are kind of... Like right now they just instantly get their Z set. One option would be to set their Z speed so that they kind of like actually get knocked down. So there's a lot we can do with that, but the system right now is good enough to kind of get the general idea. All right, so we're going to add a new script called world move. So we're just going to give we'll do it the other way around. We'll give a distance and a direction. And we're going to try to go there. So first, we're just going to say x target equals this. And our y target is our y plus length dirt y. Oh yeah, sorry, Ronan Krang. I almost started talking about adding actual gameplay to this game. That would be... How you gonna sell it, you know? How you gonna sell a game that has mechanics? People want flash. Alright, X target. We're gonna start this simple. This is just literally just put me where I'm trying to go. So up here, we have our movement direction, blah, blah, blah. And then instead we say, we'll move this frame, movement pixels, movement dir. Okay, so that still works. Now here's something odd. I'm moving at 45-degree angles, but the grid is not in 45-degree angles, so that doesn't feel right. So what do we do about this? All I'm going to do is, when we give Y movement inputs, I'm just going to multiply it by the grid ratio, which, as you may recall, is the grid height divided by the grid width. So, there. Now I'm actually moving on the grid. It's nice. So this is a bit odd from a world perspective, because if we think of viewing the world kind of downward at an angle, when I move up, I'm actually moving across the grid spaces a lot faster than when I'm moving horizontally, which is kind of interesting. So that's something we can think about resolving later if we care. Alternatively, we could just elect to not care. The Rumpus asks, was that change with the grid ratio with respect to the grid itself or with respect to the player? So the way the grid ratio works is when we initialize our grid, we get our width and our height of our grid space, and then we just calculate the grid height over the grid width. And this kind of gives us like how compressed the Y is of the grid. So for the player, all we're doing is previously we would have X and Y input values. And so let's say the grid ratio was 0.5. Now all we're going to do is we're going to always multiply our movement inputs by 0.5 so that instead of going down at full speed, we'd actually go down at half speed. Ronan Krang cares now because now you can't unsee that you're moving faster vertically. Yep, it's a problem. It's a real problem. So there's an interesting problem here, which is like, let's say I switch this, right? So I say like, I'm going to get rid of that whole movement input Y, and in my world move, when I give it a direction, now I'm going to take my grid ratio into account, right? So now I move on the, I'm moving now correctly. I'm still moving with the grid, but I'm moving slower vertically than, you know, all that. But this is a problem because I've told the player to go 45 degrees, and the player is not going 45 degrees. So now I can no longer reliably tell the player to move in a certain direction. So that's not what I want to do. This is a bigger problem with movement on an angled grid that we will have to probably tackle a little bit later. So next thing I'm going to do with our movement code is, instead of just going straight to the place where we're going, first we need to check if it's a valid location. So grid destination equals world to grid. And our destination coordinates is... And right now, our only decision metric is there a tile there? If dsmap exists, tiles spawned. Okay, so this is phase 1 of moving with the grid. Oh no, I can't do it. And actually, I'm going to go ahead and spawn... see, red. I'm going to spawn a marker at where we're trying to go, just so you can kind of get a sense of this. Okay, so I can't go here, and we end up with this weird problem where even if, let's say I press to the right, I'm not moving right at all because I'm trying to go off the tile and it's not a valid location. So that's no good. This also is a little bit weird because, of course, I am hanging halfway off and so is my shadow, which is a bit odd. There's an easy way around that, which is to just make a blurry shadow so nobody notices. The longer you guys watch this stream, the more you'll realize that many of the game dev techniques that I've learned over the years is trying to find ways to make people not notice how bad certain things are. It's a legitimate strategy. 184 by 106. That is not right. Alright, so we're going to make a shadow that is the size of the grid. Inkscape. Blur it out. I think our shadow in-game is solid black, so this is fine. And we're just going to export that as is. So... import new shadow. Alright, we got a new shadow now. We could probably blow up the size of it a little bit, but now, you know, it kind of just fades out on the edge and you don't really care. Okay, so let's solve this movement problem where I can't move. What I'd like to do is slide. So if I press to the right, then I want to be able to kind of like scoot past the edge. So Rumpus asks, is the size of a grid space in pixels or is it just a number? It is in pixels, yeah. And I'm using pixels in Inkscape also. So whenever I create something, up here at the top, there's width and a height value. And I use those so that things in Inkscape are scaled relative to how they truly would be. So for example, if I put a black outline on this, right? And I go to my stroke style and I set that black outline to 1 pixel and I export it to the game, then I want to be able to trust that that actually is 1 pixel. And so by using pixel sizes in Inkscape, then I can make sure that everything is lined up properly. All right, so let's, for the last thing to do on the stream today, let's fix this movement so that we can slide past things. All right, so we have this world move. Here we are checking whether we can go there. We're going to make a new script called world position open. And this is, we're going to just take what we just did in our movement script and we are going to have this just return true or false if the position you're trying to go is a valid position for you. Okay. So you see what we did here? We just say, if there's a tile there, world position is open. If there's not a tile there, it is not open. World move. And then here we say, if not world pos open, sorry, if it is open. And now we can get rid of this grid destination stuff. So let's quickly test this. This should just leave us exactly where we were. Okay, so still stuck. All right, so the next thing we're going to do to finalize this movement is we're going to do something that I would call an angle sweep, which is if we... First, we'll just try to go there. If we can, then we do, and we're good. If we can't, then we have a fallback mechanism where we're going to start sort of sweeping angle checks back and forth until we find an available spot. So A equals, we're going to start at, say, like 10 degrees. And we can go all the way up to 90 degrees. And we'll go by 10-degree increments. And equals -1. And for each angle, we will start in one direction and go the other direction at that same angle. So we'll go +10 -10, then +20 -20, +30 -30. So this x check is going to be x plus vector x move dist vector plus dir times angles. So we're going to check our x and our y. And I'm going to, before I do anything, I'm going to spawn markers here so we can see. So you notice we have no markers being spawned because these positions are all open. So we get out here, we've got this little curve going on. So I can actually shrink these markers down even more. So we can maybe see them. Okay, I don't know if you guys can see that on stream. There's like a tiny little arc of white dots down here. And then what we can do is world pos open. Now we can spawn a green marker if it's open and a red marker if it's not open. And that should kind of show. Right? So basically the first green marker we hit, we would just go there instead. So this kind of allows us to slide. And so as soon as we hit a world position that is open, then we go ahead and abort the whole process. I'm going to get rid of these markers. Okay, and then at the very end, we will return false, which that's just a fail-safe in case later on we need to use this script to ask whether or not we even had a successful movement. Okay, so now if I'm pressing against the wall, then I just slide. So once I get up to here, I can't really go any farther because I'm in a corner. But this now allows for really slick movement, and I can easily traverse these bridges without getting caught on things in any kind of a weird way. So now everything is very smooth to run around. And I actually have a Yo-Yo Games tech blog about this. If you just Google, I think, buttery smooth movement, then that'll be the first thing that comes up. And later on, we can also update our world movement script to account for solid instances in the world. So I think maybe tomorrow during the stream. So I'll be streaming at the same time tomorrow, 10 o'clock Central Time. I think we could probably get some kind of objects being spawned in the world, as well as some kind of things to fight. And we can maybe even start to thematically figure out what this is, because right now, of course, this is just like a Quadrupus Rampage ripoff, which we don't necessarily want to do. We'd like to do something, you know, fresh. So we could like put this in the clouds, we could put this in space, we can kind of figure out what we want these tiles to look like, and do something thematically a little bit more interesting. So yeah, we've got a lot of options here. So thank you guys for coming today, and hopefully I will see you all back here tomorrow. So have a good Saturday.